So for this particular one, we're going to look at using all the other identities and um, how to manipulate things and make things work for us. So this first one, um, they want us to write the expression as a sum or a difference of sine 4x cosine 6x. So what's interesting about this one is you got to figure out what am I going to use on my foldable? What particular part of my foldable should I be using? So if you look at it, I have a product, and so I need to turn the product into a sum. So if I'm going to put the product into a sum, I'm going to do just that. So to use that foldable the product to a sum. So I'm looking for the combination of sine and cosine. So I have it. The sine of x and the cosine of y. This would be so the sine of 4x cosine of 6x equals, and that's going to equal 1 half. It's going to equal 1 half the sine of 4x plus 6x plus the sine of 4x minus 6x. And we're almost done. Now we got 1 half sine 10x plus sine of negative 2x. All right, we're almost there. We are actually not allowed to have the negative 2x, but I do have in my old foldable, I can do this. See if this makes, whoops, sine of 10x minus sine of 2x. And to make this a little bit better, it's 1 half sine 10x minus 1 half sine 2x. So there you go. I have written this expression as a sum or a difference. All right, so I have this handy for some reason. Find sine 2x, cosine 2x, tan 2x, given that the tangent of x is equal to 3/4 for pi is less than x is less than 3 pi over 2. So what does that mean? Well, I probably should use something. I don't know if I'm using these identities or I'm using my other identities. I'm not quite sure what I'm going to use, but I need to figure out the information that is given. That is, the tan of x is 3 over 4, and that the it's in looks like the pi is less than x is less than 3 pi over 2 means that we are in a particular quadrant, which I believe we are in the third third quadrant. So um, let's do that. So let's find the sine of 2x, and let's find the cosine of 2x, and let's find the tangent of 2x, given that the tangent is 3 over 4. So for that first one, so for that first one, I guess we have to start off. What are the sines and the cosines, right? So what are the sines and the cosines? So for since it's a tangent is 3 over 4, I think that's a 3, 4, 5 triangle. So the sine of x is going to be, so if you think about it, if we want to use the triangle, that's a 3, 4, 5 triangle. So Oscar had, so 3 over 5, but it's in the third quadrant, so that's negative. The cosine of x is going to be negative 4/5. So you have those things right there. And now let's go ahead and find the sine of 2x. So the double angle identity that we're going to use, the double identity angle is um, the sine of 2x equals 2 sine x cosine x, right? I believe that's what the double angle identity is. So let's do that. The sine of 2x is equal to 2 sine x cosine x. So the sine of 2x is going to be 2 times negative 3/5 times negative 4/5. So the sine of 2x is equal to 2 times negative or positive 12 over 25, or sine of 2x is equal to 24 over 25. So the double angle sine of 2x is equal to 24 over 25. Find the cosine of 2x. Find the cosine of 2x. The cosine of 2x is equal to, the cosine of 2x is cosine squared x minus sine squared x. So cosine squared x minus sine squared x. So cosine is negative 4/5, so I'm going to take negative 4/5, square it, minus negative 3/5 and square that. So what does that become? That becomes 16 over 25 minus 9 over 25, which gets me 16 minus 9, I believe, is 7 over 25. But we are in the third quadrant, so I guess it got to be negative 7 over 25, right? And then the tangent of 2x, I believe the tangent of 2x is equal to 2 tan x over 1 minus tangent squared. So I don't have the tangent, so I might as well, oh yeah, I do. I have the tangent is 3/4. Tangent's 3/4, so 2 times 3/4, 2 times 3/4, 2 times 3/4 over 1 minus 3/4 squared, so that's, this goes away, that's a 2, so 3 over 2 over 1 minus 9/16. So 3 over 2 over 16 over 16 minus 9 over 16. 3 over 2 all over 16 minus, so 7 over 16. And then you flip it. All right, and that's a 1, that's an 8, so I guess you get 24 over 7. So the tangent of that double angle is 24 over 7. Right there. Oh wait, you know what? I'm sorry. It's not negative 25. It's going to be positive 25. So my bad. All right, cool. Let's look at this guy. Sine of t plus cosine of 3t over cosine of t plus cosine of 3t is equal to the tangent of 2t. How are we going to do this? How are we going to do this? So I guess the first thing we have to ask ourselves is, what are we going to do? I'm going to try to make the left side look like the right side. So I'm going to use, I got to figure something out. I noticed I have a sum upstairs and a sum downstairs. So I'm probably going to use the sum to product identity. So if I do that, if I do that, if I do the sum to product identity for the numerator and the denominator, then I'm looking at my foldable, I'm going to use it. It now becomes, the numerator becomes 2 sine t plus 3t, and that's over 2, times the cosine of t minus 3t over 2. And that's just plugging into that guy. And then over And I guess this becomes 2 cosine t plus 3t over 2 times sine t minus 3t over 2. So if we polish this up a little bit, the numerator becomes 2 sine, and then that's 3, 4t, so that's 2t times the cosine of negative t over 2 cosine 2t times the sine of negative t. We're trying to make it look like the tangent of 2t. So if we do that, I'm gonna let's see. The 2 over the 2 cancel, and then I don't know what's next. What do we do about this that's goofy? Oh yeah, it would help if I made this right. That's the cosine. That's the cosine. My bad. That's a 1. We're left with the sine of 2t over the cosine of 2t, which becomes the tangent of 2t. That was awesome. So hopefully this makes sense, and I'll see you in class real soon, and may the